All right, welcome to section 2, guys. And in this section, what you're going to be looking at is bipediality in relation to childbirth. And so evolutionarily wise, what happens when we move from being a quadruped, so here's our lovely quadruped, this is a chimpanzee, one of our closest relatives, about 99.3% similar molecularly to us. But our relatives were not chimpanzees. Don't let anyone tell you you're a chimpanzee or an ape, you're not. But we have a common ancestor, a last common ancestor. We don't know what that is. We haven't found that yet. But we are closely related. These guys are terrestrial quadrupeds. We are considered obligate bipeds, and the reason we're called obligate bipeds is because it's kind of non-negotiable. If I start running around on all fours, you guys are going to judge me a little bit. And so you're expecting to see Homo sapiens walk around on 2 legs, and there's a number of adaptations that come along with being on 2 feet that we're going to examine, including childbirth. And so I want to point out on our good friend here, our pan-troglodyte, which is our chimpanzee friend. You can see here that this is the girdle of the pelvis. It's very thin and it doesn't have to be very robust. And the reason that it can be a little more gracile versus kind of chunkier and robust is because the weight is evenly distributed. And so when you're a quadruped and you've got all four limbs on the ground, that weight is nice and even. As soon as we stand upright, all the weight is concentrated on our pelvic girdle, or a lot of the weight is concentrated on our pelvic girdle. And Homo sapien pelvic girdles are not only a little bit more robust, but they actually had to change in shape, specifically in relationship to walking, our walking gait. So if we continued to have hips that were shaped like this, we would walk like you see apes walk, which is that really funny kind of drunk grandpa walk, right, like this. But what's happened is our hips have angled our femurs in, so we can walk nice like this and not have that weird kind of gait that you see when sometimes our chimpanzee friends walk upright. So we're going to go ahead and move on from our chimpanzee, remembering that he's quadrupedal and he's got a little more gracile pelvic girth. And then we're going to kind of compare the chimpanzee pelvic girth to our Homo sapien pelvic girth and see what those adaptations are. All right, so let's move on over. And we can see here, the first thing I'm going to show you is yours. This is your pelvic girdle, which you have here. And you'll notice if we kind of hold it up side by side like this, you can see this one, just like it is in the chimp over there, is much more gracile. It's longer, it's not as robust, and ours is a little bit more robust and kind of chunky. All right, now, what does that have to do with childbirth, you're going to ask? What's the big deal about that? If you were in class, you would be getting your hands on these materials and you would actually kind of be reenacting the birth, okay? Now, this is kind of a miraculous birth because right now we're going to have a chimpanzee give birth to a human. And this is a 34-week-old fetus. And so now you should ask yourself the question, how many weeks do humans gestate? And so that's in your book and you will be able to kind of figure out what the comparison is. But once you do, you'll discover that a 34-old week human fetus is actually almost full term. So it's almost full term. So keep in mind, this isn't even a full-size human baby head. All right, but here is the pelvic girdle for the chimpanzee. And here is, again, it's a miracle, it's giving birth to a human. And you can see, if you were in the lab, you'd be able to take this human head and move it right through the birth canal. It seems to have a lot of space to it. It's kind of easy to kind of get that through there. If we take now the Homo sapien pelvic girdle, okay, first thing you're going to notice is it's a lot more narrow and the tailbone kind of comes up there. And so you can see getting that head through that area right there is a lot tighter of a fit, which is why you will see when it comes to the effort in giving birth that chimpanzees have a lot more ease giving birth than Homo sapien females do. And if you ever talk to someone that's had a baby, they'll tell you, yeah, it's a little difficult to kind of accomplish that task. So the question comes for you guys is to say, why do we select for this? Why, especially when bipediality makes it harder to give birth, why was this trait actually selected for over time? And so now you're thinking about why natural selection chose this upright feature when it made it so hard for us to actually give birth. All right, guys, so don't forget when you're looking through this section, make sure you look at the notes that I've put for you in the gray box. Those are the facts that you'll need to kind of answer this hypothesis. As you work through this section, you're also going to be dealing with the different hypotheses that go along with bipediality and why scientists think we evolved bipedal locomotion. There's about 4 to 6 of them that you need to have in your notes. And then you also need to make sure that you tell me which one of the hypotheses has the greatest explanatory power and the one that has the least explanatory power, meaning scientists don't think it really tells you why we're bipedal. And then of course, alternative, pick the one that the scientists believe tells us really why we got to the point where we're up on 2 feet instead of quadrupedal like our good friend here. All right, guys, good job. Let's move on to section 3.